Welcome to this month's live question time. Today I have the privilege to be joined by Steve Schickel from LK Metrology, Sales and Marketing Director. In these unprecedented times, we are actually working remotely from our homes. Unfortunately, Gina can't be with us today and we wish her a speedy recovery. Steve, welcome to the live question time. How are you, my friend?
Hi, good afternoon, Gio. Hope everyone can hear me. There's a little bit of feedback here.
How are you, Steve? Can you hear me okay?
I can hear you, but I'm actually getting your question repeated about 10 seconds later.
Right, I'm sorry about this, Steve. I don't know what's causing the lag. Steve, this is the first time that we've done a question time like this, and obviously, like we mentioned, it's unprecedented times. However, it is what it is. It's amazing to see the engineering community pulling together as they are. How are LK finding the current climate?
Yeah, sorry, Gio. It's a little bit awkward because I'm getting a big delay in the question. So, so first of all, thank you for inviting me onto this question time. Hopefully, we can have some good questions from some of the viewers. And obviously, the current climate's it's unprecedented. It's certainly changed massively over the last couple of weeks. I mean, who'd have thought? A couple of weeks ago, people were selling shows and exhibitions, but obviously things have changed a little bit now. We've had to make some changes. We're obviously working from home, which it's nice in some respects, but it's obviously has its own challenges. We can't manufacture CMMs from home, so we still have a skeleton workforce, still manufacturing our machines.
Brilliant, Steve. Now, Steve, you've been in the engineering industry for many years, so let's start with your journey into manufacturing and engineering first. You've had a brilliant career so far. Tell us about some of the companies that you've worked for and why you got into engineering in the first place.
Yeah, that's a good question. I kind of obviously looked at my father and my grandfather. They were working in industry, camellards. They'd worked in as fitter turners, that sort of stuff. So I've always had a bit of an engineering sort of interest. And in all fairness, British Aerospace is local to us. So we know today, it's Airbus Broughton. So effectively, I left school wanting to go into engineering. I got a job down at Airbus Broughton as a craft apprentice. So the first sort of 12 months, you're actually trying to find which specific area in engineering that really suits you. So I can remember going around different sections, everything from electrical through to joinery, tin bashing through to machining and tool making. And machinery was something that I actually quite liked. I quite liked the concept of making precision parts. Then basically in my second year, I started working on the larger machines down in Airbus, and also going around to the section, cutter grinding, stuff like that. And then effectively, I spent a lot of time in precision gauge control. So that actually gave me the first insight into metrology, which I found really interesting because there's so many different facets to it. So whilst I was at Airbus, I was involved in so many projects, and also looking at gaugeless tooling philosophy. So effectively going away from static heights and master preferences, using digital metrology. So using optical measurement systems, photogrammetry, laser tracking, sort of stuff. So, and then that basically led me into my first sales career, which was with LK Geosystems. So effectively taking everything that we'd learned from industry using laser trackers and put it out there to all the rest of the industry. So I got involved in Airbus A380 projects, A400M, lots of military projects with JSF, Typhoon, and so I had some great success there. And then that company was bought by Hexagon Metrology back in 2006. And then that's when basically I was made up to UK sales manager for multiple measurement devices. That kind of led through to about 2017. And then I went to work for another company who did inline measurement systems, again using laser trackers and scanning systems. And then more recently, I've been working with LK Metrology, and it's been great so far. It's been a good opportunity to work with yourselves to help relaunch our brand.
Brilliant, Steve. I mean, LK Metrology, you're now sales and marketing director. The company has a strong heritage. It was established in 1963, I believe. Now, can you tell us a little bit about LK Metrology as a company, how it started, some of the innovations that they are renowned for? They were first at many innovations, really, Steve. Can you kind of tell us the story, how they started?
Yeah, so basically, back in 1963, it was founded by basically a Rolls-Royce engineer. Him and his father set up LK. It was actually not metrology at this time, it was a tooling company. And basically, so that was Norman Key and Jim Lowther, so hence the name the L and K. So effectively, they got involved in building and designing coordinate measurement machines. And the first machines that they built were actually to help develop a touch trigger probe head, which is now known as the Renishaw touch trigger probe head. So they worked in the very early days with Sir David McMurtry to help him develop his first probe head. From there on, obviously, the design of coordinate measurement machines, and with new electronics and computers and software, LK developed the first bridge coordinate measurement machine, and that's become a standard today. But it's had many firsts, many innovations with using different types of material. Looking at, initially they were using granite, and granite, as we know, is a very stable material. But if you're using that in the bridge construction, it's very heavy, and that basically slows the machine down. So we looked at using composite materials, but now today we've actually standardized on using ceramic technology. So it's got exactly the same characteristics as granite in terms of it's very thermally stable, very stiff, but also it's very lightweight as well. So that gives us the ability to be able to move the machine very quickly. Gives us a very thermal coefficient standard machine, so it's stable.
Steve, we've just had a question come in live. One of the questions I was going to actually ask you myself, to be fair. Now, this is a question from Tom Skabula on Instagram. How metrology will help him become more profitable? Can you give some examples? Because I do assume, and I can see where it's coming from, a lot of people see metrology in inspection as actually a cost to them, not a way in which they can be more profitable.
Good question, and I guess it does depend upon what he's actually doing from a manufacturing perspective. But ultimately, without metrology, you don't know what you're actually producing. So it's a quality gate. So effectively, if you can measure your components coming off your manufacturing process, you can obviously ratify to see whether they're intolerant or not. And if they're intolerant, then great, you can obviously then start producing more of them. But if you actually don't check, and your customer finds the problem, ultimately your reputation is at risk, and you could have lost business, you could have lost revenues. So for me, metrology is imperative. It's part of the manufacturing process. Once you've actually ratified that you've got a stable process, then you can start making it even better by using metrology to hone down all the processes to make it more and more stable and reproducible.
Now, I totally agree, really, Steve. I see so many people investing in the latest machine tools for producing the parts, and maybe they're not kind of investing the same kind of money into metrology. Now, there is an argument to say that this is not the right thing to do, because if you're producing the parts faster, you need to be checking them faster. And you've got many new solutions to do that also, Steve, with some of the automation solutions that I've had the luxury to see at your facility in Castle Donington.
Yeah, that's right. So as you say, if you're producing parts, you've got takt time of minutes, and ultimately quality can get in the way. So unless you can speed up quality and you can actually make things a lot faster and check them quicker, then it will become a bottleneck. So we've recognised also that you've got to look at the total cost of quality. It's not just the cost of the CMM, it can also be the cost of the labour that operates the CMM. So basically what we do is we look at automating the sort of tending. So you can take a part, put it onto a machine, turn the part or mill the part, take it out of the machine, using the robot and automation, put it into the conveyor system, take it to the CMM, automate picking and placing on the CMM, fully automatic inspection process. And then obviously if the part's good, it goes to the next stage of the process. If the part needs rework, then ultimately you can go into another batch to get reworked or obviously scrap too. But it's also what you do with that data. You know, ultimately that you can't manage your process unless you're measuring it. So once you've actually captured all this information, you should be using that data wisely, looking at your KPIs, your SPC analysis, looking at where you're seeing trends, where things are actually going out of tolerance. And ultimately, you can then pinpoint where the problematic areas are, make adjustments to the process, and ultimately get a better quality, more conforming part.
Now, you mentioned the bridge construction CMMs, which you manufacture in Castle Donington for all around the world. Now, these are not the only products that you also offer. You've got 3D scanning technology now. You've just launched as well the Freedom Arm and the Altera C. Can you tell us a bit more about some of the new products that you've brought to market and some of the existing ones too? You know, you haven't actually got a largest size, if you like. You make your CMMs to suit the application, whatever the size.
That's right. That's one of the strengths that LK has got as a company. For sure, we've got a standard range of products. The standard range of products covers most of the market, but there's always going to be those customers that have got a very specific requirement, which basically requires the engineering team to sit down and design and scope out the whole machine from start to finish. And so we've got a few examples of that we've worked on in the past. And then obviously we're trying to broaden our scope a little bit by introducing a range of portable arms, and because ultimately they can complement the CMM. If you're doing quick setups on a machine tool, it's nice to have an arm that you can take to the machine tool and do a very quick measurement to prove out that things are good. Or you could even use it to help doing a setup on a machine. So if you're machining casting, the idea there is that you want to be able to make sure you've got net material. The last thing you want to do is machine all these important faces and then find out that you've actually got no material to cut and you've got a rough face. So basically, we recognised that we needed to bring portable metrology into the portfolio that LK got to offer. And so now we offer a range of arms from 2 meters all the way up to 4.5 meters, and we also offer them with laser scanning. So with laser scanning, we're getting up to 1 million points per second. Realistically, we drill down and get around about 500,000 points per second, and that's great for very quickly color mapping problematic areas or for doing reverse engineering. But then I think also for me that it's the software. It's where we're going in the future with software. So we're in the process of launching a software suite called Metrology Gate, which effectively is a true Industry 4 software suite. So you'll be able to actually have a very real-time oil delivery, real-time KPIs and SPC analysis. You'll be able to see if first of all, if the machine's in good health. You can also look at PPMs on the CMM, how many touches has the touch trigger probe made, because again, there's only a certain amount of touches that they do in its lifetime. You've also got then the ability to look at all the reports coming off the machine. So again, if you've got parts that start to drift outside tolerance, stop the process, investigate, and then find out where things have gone wrong. And then ultimately, you're only focusing on the problematic areas. Ideally, everything will be good and everything will be in tolerance. But so obviously, this is where we're going with software to make it more unique. Use it with an app on your phone. You have a dashboard to run your whole company.
Well, talking about software, we've just had another question come in live, Steve, regarding the software. Now, we've had a question: what software would you use if you had to extract challenging geometry from complex point clouds? That's from Nick Alimaras on YouTube.
Yeah, so that's a good question, and as I said, we're seeing that today we're collecting more and more data, and if we actually look at laser scanning, you could be collecting millions of points, and you're using those points to be able to extract geometry such as holes, slots, edges, cylinders, and sometimes if you're measuring turbine blades, you might actually be struggling to pick up some of these features. So from experience, I would say Polyworks offers a good software suite for that, because they can really drill down into the point cloud, and with search routines and macros, you can actually get good data. So to answer the question, I would say Polyworks is a good software.
Now, software, you actually manufacture your own software as well. Can you tell us about that and what it's called, please, Steve?
That's right, yeah. So obviously, since the early days, we've had our own software suite. I think 2003, we launched a new package called Cameo. So Cameo is developed by our software engineers based out of Castle Donington. So effectively, it goes on our CMM for inspection CAD. We've got full GD&T capability, and we're also now bringing in PMI data. So rather than just bringing in a done CAD file, we can now start bringing in all the GD&T tolerances, product manufacturing information. So, but again, all of this is done from our engineers based out of Castle Donington. We've also now starting to embed it into the production process. So again, going back to what I was saying before, if you've got inspection results, what are you actually doing with that data? Gone are the days where the guy used to print it off and have a fan-fold report of paper and then pass it to production. Ideally now you want the information to go straight into the production system. So again, you can start looking at KPIs and stuff like that and SPP analysis. So that's all done out of our site in Castle Donington, and that's where we're going in the future.
I've got plenty more questions for you, Steve. However, another live question's just come in. What, in your opinion, would be the best way to measure on a machining center or a lathe? That's from Joanne Ikovov on YouTube. Sorry if I've not pronounced your name correctly.
That's okay. I suppose it depends on what you're actually you're manufacturing. Sometimes on a lathe, if it's just straightforward diameters, then there are standard measurement systems like micrometers and gauges and verniers. But ultimately, it depends on what you're actually turning. If you've got 5-axis capability and it's all against CAD models, then you need something that's a bit more involved. So therefore, there is on-machine inspection too. And we're also looking to go down that avenue in the future with our systems too. So on-machine probing to compare against CAD models. But also, if it's a very large part, then ultimately you can bring an arm to the lathe. Some of these lathes I've seen in industry, they can have a chuck that's got a diameter of 2-3 meters. So then it becomes quite cumbersome to be able to measure with a micrometer. So again, it just all goes down to tolerances. So then maybe an arm brought to the lathe, put on the lathe bed, and then you start probing and doing inspection against the design intent.
Even with the Altera C now, Steve, you can bring that onto the shop floor now. That doesn't need a temperature controlled room, does it? That can be next to your machine.
If you look at, yeah, so to be honest with all of our range of CMMs, there is an element of how ruggedized are they for the shop floor. So basically, we use a lot of ceramic technology. So because we're using this thermally stable material, that basically means that we can work in more wider temperature ranges. I mean, ultimately, we always say it's also down to cleanliness too. So, if the CMM is obviously coated in a lot of carbon dust, then you may need to have more planned preventative maintenance. But yeah, so ideally, we'd have a machine that's sat next to the production process. And again, if we're using machine tending, then ultimately we're taking the part of the machine center, putting it on the CMM, running through its process, and obviously it'll either pass or fail, go to the next stage.
Now, keep them questions coming in, please. Any more questions that you've got for Steve, don't forget to ask them during this show. Anything you want. Now, in regards to new products and technology, Mac was supposed to be just around the corner, Steve, and we were going to be looking at your virtual reality kind of shop floor environment, the digitalized environment, and which kind of encompasses Industry 4.0. Can you tell us a little bit about this, please, Steve?
That's right. I mean, one of the things that we've been trying to do is educate the market about our full capability. And we really do value shows and exhibitions. That's where customers got the ability to come and see what we're actually produce. There's a problem with that though, and that is that we actually have a full range of machines that can go up to 10, 15 meters. So we're not able to bring those to shows or exhibitions. What we've actually started doing now is we're designing and developing a virtual factory, a full range of our machines that we can actually then show to customers using virtual reality. So you can come to our stand, you can actually put a VR headset on and walk inside a factory and then see the full range of CMMs that we've got to offer. So that's one way of looking at it. But again, going back to the Industry 4 side of things, this is all about using the data wisely and also getting real-time information from the machine. So ultimately, you've got a dashboard to run your whole inspection area. And again, you can use an app on your phone. Effectively, when there's a problematic area, you get a ping on your phone. The app gives you a quick dashboard and shows you problematically where the errors are. So the idea of Mac this year, we were going to have the virtual reality system, but also we're going to have all of our machines linked through to this Industry 4 software, which is called Metrology Gate, one of the software suites that we have.
Well, this sounds fantastic, and we can't wait to see this really in January when Mac rescheduled for. Now, in regards to the virtual reality, what are the benefits are there in regards to you know, for a big organisation, for example, Steve, say for example, some of your big organisations such as Jaguar Land Rover or Rolls-Royce, what advantages would it have for them in regards to planning or future planning? Can they do this? Will this save time?
Yeah, so the software suite that we've partnered with is a company called Visual Components. So effectively, they specialise in creating virtual digital factories, and they have what we call an e-catalog, which effectively has robots, conveyor systems, fencing, you know, all of the things that you can actually build into a factory. So if you look at, say, Jaguar Land Rover, and sure, they're constantly challenged with changeovers between vehicle types. So when they're designing a brand new vehicle, there's always the rundown of the current process. Got to strip down the factory and then rebuild the production line using obviously as much resource and limited time as possible. So by using Visual Component software, got the ability to build all of this offline and design and test the whole production environment. So effectively, once you've proven it out digitally, when it comes to actually delivering it, you get it right first time. Everything, all the PLCs, controllers, it's already been pre-tested. So you know that when you bolt it together and install it, it will work because it's already been tested offline. So you can appreciate that will save months, if not, you know, probably save 6 months on a project if you do it all right offline. But also you can map it out. You can map your production space. You can use scanners today to scan buildings. Take this point cloud, put it into the virtual software, and then you've got the ability to optimize the layout of all of the production processes and optimize them. Again, you make changes in the software. It's a lot safer and cheaper than to do it whilst you're doing an install. So again, it just saves a lot of time, energy, money, and effort. But also, it's also good as a proving tool to improve process before you've actually built it.
I suppose as well, Steve, in this current climate, it's a way in which you can work remotely. We've just had another question come in live from Paul Burton at Arnold Rag. I believe he's referring to the Altera C. His question is, I've seen a video on MTD CNC and you have a CMM that is for the shop floor. How does the machine stay stable and achieve a reliable measurement?
So it's a good question to come in because obviously, if you look at the shop floor environment, there's always going to be external forces on that machine. So we generally have the option to put what we call AVMs. so anti-vibration mounts. So the TMM sits on a bed, which is on an air cushion. So in theory, you could actually sit on the machine and it will still measure precisely. So the idea is that if it's independently mounted on these AVMs, that takes away all of the vibration from the shop floor perspective. What I would also say is, if it's a very dirty environment, as we do see some machine shops, there's a lot of coolant, mist. We can also put an enclosure around it. So effectively, you can protect the machine from all the environmental effects.
Brilliant, Steve. Now, keep them questions coming in. Steve will announce shortly the winner of the £100 Amazon voucher. We had a competition during the month on LinkedIn. Now, education, Steve, education is key. In your opinion, why is it so important to keep up with the latest technologies and innovations, not just from a learning perspective, but from a company perspective too?
That's a good question, because ultimately, if you look back at when we were serving our apprenticeships, how technology has moved from that, and even if you just look at computers, the way they've evolved over the years, and how we've got this Internet of Things. So I think certainly in manufacturing, it's vitally important to make sure that you're kept abreast of technology, because it's changing so quickly. There's new innovations coming out every day. This is why I like to go to the Mac exhibitions, because you get to see exactly what's been evolved over the last sort of 12 months. We've seen a massive influx of additive manufacturing over the last sort of 15 years, and that's now getting to a stage where we're going to start seeing it in production, rather for production parts as opposed to R&D parts. So yeah, so I think obviously training, keeping abreast of things is vital, and I think MTD CNC offer a really good avenue into that. So this is where we like to partner with you guys, because it gives us the opportunity to promote our new technologies with you.
Now, you mentioned additive manufacturing. Does that kind of change the landscape of measurement and metrology? The parts are becoming so much more complex. How has that affected the way in which you inspect them?
Yeah, that's right, because obviously you can make things now that actually can be impossible to measure with conventional techniques. So what we've seen is there's a lot more demand now for laser scanning, so we can scan these additive manufactured parts. But also, if you want to measure the internals, then this is where you need to start looking at CT scanning. So CT scanning has also evolved over the last sort of 10, 15 years. To obviously keep up with the demand from additive manufacturing capabilities. So for sure, yeah, it's a challenge, but there are technologies out there that complement it.
Gina's at home watching, Steve, and she's wondering if she's won the Amazon voucher. Can you please announce the winner, please?
Okay, so back at Farnborough, where we had Southern Manufacturing, we had a competition, and basically one of my colleagues was scanning my face with the new Freedom Arm scanner, and so the question was, who was he scanning? So I'm pleased to announce that we do have a winner, and it was the first response that we had online, and that is a guy called Craig Henningham, and he works for Power Talk Engineering.
Congratulations, Craig. Your Amazon voucher will be on its way. Now, Steve, thank you very much for joining us today. I mean, it's really been brilliant to see how the manufacturing industry is really pulling together during this challenging time. I've heard so many stories of people changing their production to produce medical parts. It's absolutely fantastic. So please, everyone, keep up the good work. We at MTD will continue as normal, as safely as we possibly can. What messages have you got for everyone, Steve, out there? Us manufacturers, and most manufacturers need to carry on.
No, absolutely. And as I say, I'd like to add to that, if anybody needs any support in metrology, we're certainly the manufacturer of these medical devices. Please contact us, reach out to us. We've got capability. We've obviously got machines that are available. But also, what I'd like to say is let's keep working together. Let's keep British manufacturing strong as well. I think that's vitally important. And as I say, I would just like to say to everybody, remain safe, follow government guidelines. I'd also like to say to a lot of manufacturers, look after your staff. You're going to need them. Once we've got through this situation, hopefully you're going to see a big boom. And those should be the golden years. So look after your staff now, and you'll all be there together to reap the rewards later.
Steve, it's been an absolute pleasure having you today. Thank you very much for your time. If you watched this show, please like, comment and subscribe. The next question time will be the last Monday of next month. So we'll be promoting it throughout the month on all social media platforms. So keep tuned and stay in touch. Stay safe from MTD CNC Question Time.
Thank you very much.